Hello everyone, welcome back to our channel. Today we're going to explore how to prepare salts using various methods. Salts are essential compounds in chemistry, and there are several ways to prepare them depending on the reactants and conditions. In this video we'll cover the preparation of salts by ionic precipitation, titration, direct combination, and reactions involving acids with metals, insoluble bases, and insoluble carbonates. Let's dive in. First, let's talk about ionic precipitation. This method is used to prepare insoluble salts. It involves mixing two solutions, each containing ions that will react to form an insoluble salt, which then precipitates out of the solution. For example, if you want to prepare barium sulfate, BaSO4, you can mix a solution of barium chloride, BaCl2, with a solution of sodium sulfate, Na2SO4. The barium ions, Ba2+, will react with the sulfate ions SO42- to form barium sulfate, BaSO4, which is insoluble and precipitates out as a white solid. The steps for this method are straightforward. First, prepare the two solutions containing the ions you need. Then, mix the solutions together. Filter the mixture to collect the precipitate. Wash the precipitate with distilled water to remove soluble impurities. Finally, dry the precipitate to obtain the pure salt. Remember, once the salt you want to prepare is insoluble, you must use ionic precipitation. Next, we have titration, a method used to prepare soluble salts, particularly those of strong acids and strong bases. We use this method especially to prepare salts of sodium, potassium, and ammonium. Titration involves carefully adding a solution of an acid to a solution of a base until neutralization occurs, producing a salt and water. The acid provides the anion of the salt you want to prepare, while the base provides the cation. For example, if you want to prepare sodium chloride, NaCl, you can titrate hydrochloric acid, HCl, with sodium hydroxide, NaOH. The two will react to form sodium chloride, NaCl, and water. Here are the steps in this method. Measure a specific volume of the base solution using a pipette and place it in a conical flask. Add a few drops of an indicator, like phenolphthalein, to the base solution. Slowly add the acid from a burette while constantly swirling the flask until the indicator shows that neutralization has occurred by a permanent color change. Repeat the titration to get an accurate reading of the volume of acid and base required to neutralize each other. Now repeat the titration with the volumes determined, but this time without the indicator, so that the acid and base neutralize each other, leaving only the salt and water. Evaporate the water from the neutralized solution to crystallize the salt. Dry the crystals to obtain the pure salt. Direct combination is a simple method used to prepare salts by directly combining two elements. This method is typically used for preparing salts of reactive metals with non-metals. It is used particularly when preparing simple anhydrous salts like metal chlorides. For example, to form iron 3 chloride, FeCl3, we can heat a sample of iron, Fe, over a stream of chlorine gas, Cl2, and the elements combine to form the salt. The steps are as follows. React the metal with the non-metal in a controlled environment. Heat may be required. The salt forms directly from the reaction. If necessary, purify the salt by sublimation or recrystallization. Another common method in the preparation of soluble salts is the reaction of an acid with a metal, insoluble base, or insoluble carbonate. The principle behind these reactions are pretty much the same. Preparation of salts by reaction of acid with metal. The reaction of an acid with a metal produces hydrogen gas and a salt. This method is typically used for preparing soluble salts of moderately reactive metals. For example, if you want to prepare zinc sulfate, you can react zinc with sulfuric acid, which produces zinc sulfate and hydrogen gas. The steps are as follows. Add the metal to the acid in a reaction vessel. Allow the reaction to proceed until the metal is fully dissolved. Continue adding more metal until the reaction stops. There is no more effervescence and excess metal remains. Filter out any unreacted metal and collect the filtrate. Evaporate the solution to crystallize the salt. Dry the crystals to obtain the pure salt. Preparation of salts by reaction of acid with insoluble base. Reacting an acid with an insoluble base also produces a salt along with water. This method is useful for preparing soluble salts of weak acids or bases. For instance, when preparing copper 2 chloride, we can react copper 2 oxide with hydrochloric acid, which forms copper 2 chloride and water. The method is as follows. Add the insoluble base to the acid. Stir the mixture until the base has reacted completely and excess base remains undissolved in the mixture. Heat may be required to ensure the reaction is complete. Filter the solution to remove any unreacted base and collect the filtrate. Evaporate the solution to crystallize the salt. Dry the crystals to obtain the pure salt. Lastly, we have the reaction of an acid with an insoluble carbonate. This method is similar to the reaction with an insoluble base, but it also releases carbon dioxide gas. For example, the preparation of calcium chloride can be performed by reacting calcium carbonate with hydrochloric acid. This produces calcium chloride, water, and carbon dioxide gas. The steps for this method are as follows. Add the insoluble carbonate to the acid in a reaction vessel in excess. Allow the reaction to proceed until effervescence stops, indicating the carbonate is fully reacted. Filter the solution to remove the unreacted carbonate and collect the filtrate. Evaporate the solution and crystallize the salt. Dry the crystals to obtain the pure salt. And that's how you prepare salts using various methods, whether it's by ionic precipitation, titration, direct combination, or reactions with acids. There's a method for every type of salt you need. You just have to pay attention to the nature of the salt you want to prepare. Decide on which method is the most suitable and select the appropriate starting reagents. I hope you found this video informative and enjoyable. If you did, please give us a thumbs up. Leave a comment if you have any questions, and don't forget to subscribe to our channel for more chemistry content. Thanks for watching, and keep exploring the wonders of science.